So actually there is no clear linear pattern, because the pattern, this goes down and then starts going up slowly. Now this here, it doesn't seem to go up very sharply. So there is no serious disadvantage in having slightly larger modules. So intuitively we would think that it should be bad. But based on the data available, having larger modules here, that doesn't seem to be quite as, doesn't seem to have quite as much impact as here. Questions or comments? So take a look at our paper and see if you have any comments there. So we did this work a while ago, but we have occasionally looked at the literature, and I think our results, our observations still valid. So the data that has come out that supports what we had said. And okay, oh, incidentally, next Tuesday, I would not be here, so instead we will have, let us have a discussion. So, I know this is a small group, which is probably not bad for a discussion. So prepare to share some ideas about what project you are thinking about, and give a something like 7-minute or so discussion. So prepare prepare some ideas about what you are thinking. Now, when is the proposal due?
It's already due.
Oh, it's already due. Okay. Oh, I guess I haven't checked. So it's in REMCT.
Yeah.
Okay, so I have to check REMCT. So yeah, so go ahead and discuss, and the idea is that you want to give want to find out what others are doing, and now this is a small class, so I guess you cannot collaborate. Sometimes if it's a large class, then sometimes people want to collaborate. I guess that's I don't mind that, but that's, I guess this is. I suppose that is possible, even in this, but basically, if two people collaborate, the work they do should be twice as much, and it should be clearly identified what part each person did. So, so something like, did I say 7 minutes? So this is 7. Is that the right amount of time, or is it too short?
It's fine.
I think it's too short.
That's fine.
You can present the rest of it.
Okay, so let's see. We have 4 students. So, so Henschel will make sure that people don't fight. So sometimes the discussions they degenerate. People are passionate about their point of view, so which is good. You have to be passionate, but don't fight. So yeah, so prepare your presentation. Basically, mention about what idea you are thinking about, and what you have found so far, and what direction you want to take, and then see what feedback you get from other students.
Can I record students so that they get embarrassed?
No, I guess we don't need to record.
Okay.
But one possibility is that I have tried it in the past. Maybe you can evaluate the speaker. And okay, let me prepare evaluation sheets. So each of you will evaluate the other 3 speakers, and evaluate the speaker on novelty of the idea, and how well the ideas are presented. Let's see, what else would you like to judge? And I will take a look at your evaluation. This will be just simple evaluation. I will take a look at your evaluation, but that will be for my information. I will not, when I will evaluate your project, I will use my judgment. but would be interesting for me to think what you people think. So don't worry if you get criticism from your friends. And actually, you know what I have found? That I have been in conferences and I have found that a paper that gets criticized by a lot of people, sometimes that turns out to be the important contribution.
Right.
Because if it is something that a lot of people don't like, that means that maybe there is something new, idea that threatens the existing views.
Right.
So getting negative comments are not necessarily bad. Sometimes it is bad, it is hard to say. So if you have, how many of you have your papers reviewed by others? Okay, so you have probably seen some bad comments, right?
Sure.
And some good comments.
Yes.
So, yeah, if you're going to be doing research, then you have to get used to bad comments. So, which is kind of shocking when you get back the comments after your very first submission to see what people say about your work, and sometimes even without really understanding your work.
Exactly.
So, but that's how it works. So, anyway, so we'll have presentations next time, and so I'm actually going to be away for an accreditation visit, and I cannot tell you where because that is confidential. So the accreditation process is confidential. And it is actually going to be a lot of work, but I guess that's how the process works. So, okay, so let's come back to our defect density model. So we're talking about factors that control defect density. And finally, let us come to requirement volatility. So when people start writing a program, first they meet with people who need the software. So there's people who are writing the software, and there's people who need the software. So basically you interview people who need the software, ask them about what they want, and come up with some requirements that this software that is proposed that should satisfy. And so, however, it happens that as you are developing your software, you continue to be in touch with people who need the software, and time to time they will say that no, we changed our mind. We just realized that we actually need something slightly different. And so this is referred to as the requirement volatility. The requirements keep changing while the program is being developed. And that can cause a lot of impact, because you have developed your software, you have done some testing, and then now you have to throw out some part of it and maybe replace it by some new software. And whenever you introduce new software, anything new is likely to have more defects, right? Because it has not undergone testing. And so notice that impact of change of requirement would depend on the degree of change and when the change occurs. So if the change occurs later, then you have a much bigger impact compared with if the change had occurred earlier. Only if these people had told you earlier that they want to change your mind about something, then you could have done a better job. But when you are getting close to release, suddenly they come and they say that this requirement is changed. So if we did a study, and we did some modeling. So the same change could have this type of impact on defect density, and this is the time of requirement change. So if the requirements are changed close to here, then there will be more impact on the defect density. Now this is also reflected in what they call code churn. Code churn is when you keep on changing your code. And so I was looking at some recent Microsoft studies, and they also conclude that code churn is a major culprit in defects. So it can really insert a lot of defects. It can cause a lot of defects in the code. Okay, now let us consider how this defect density model can be used. So we have this proposed model, and then there are other models. So how can these models be used? Now notice that any static model is not expected to apply, it's not expected to give you totally accurate results, because it is based on what you know, and what you know is limited. Okay, I guess maybe we should continue next time. So next time we will continue with how this model should be used, and I will show an example. And then we will go to the other aspect of reliability. So after reliability, which would be the dynamic reliability growth, and we will take a look at reliability growth modeling. So we'll continue next time.
May I record students if students are allowed to do that?
I'm sorry, what's that?
May I record students if students are allowed to do that? Probably that help for our online students, I guess.
Oh, you mean the next time?
Yes, sir.
For yeah, let's not record it.
Okay.
But you can be here as a mediator.
Why?
So